today. My name is Mani Ganesan. I am the head of product here at Prosimo. This session, I'm going to be talking about three things. What is the platform architecture? What are the key use cases that our customers are currently deploying for, and how are we different? And then I'll talk through all of that. And all the use cases I'm going to be talking about in this session, we'll demo each one of them in the upcoming sessions. So what does the platform architecture look like? If you look at this picture, you have users on the left, different types of users, B2B partners, contractors, employees, different types of enterprise users coming from all over the world. If you take a global enterprise, they are as distributed as they can get in the current world. And on the right, you have applications that could be spread across multiple types of clouds, right? It doesn't have to be the same application is spread across some components running in one cloud versus the other. I'm not talking about that. But if you take an enterprise application corpus, hundreds, if not thousands of applications, some are in the data center, some are running in one cloud, some others are running in the other cloud, and some are running in the edge cloud. And they could be anywhere. They're all different, like Ramesh talked about. What we are building is a layer in the middle, the multi-cloud transit layer. So what you see as the Prosimo icon, the P icon that you see there, is that data plane element. We call that an AXI edge, application experience infrastructure edge, or a gateway that runs in customer's own cloud. If I'm an enterprise, I have 3 regions in Azure, a couple of regions in GCP, a couple of regions in AWS. I still have my 3 or 4 data centers. So that footprint gets discovered. And one per region, you go deploy this AXI gateway or AXI edge in each of those regions. And everything is orchestrated by the Prosimo SaaS dashboard that you see on top. And it's just not only an orchestration layer. So all the feedback that we talked about in terms of all the data, the transactions, or how do we optimize for cost, all those the command and control comes from the Prosimo orchestrator that sits on top. And the AXI gateway, just to double click on it, it's not a virtual appliance. It's not another virtual router that's just sitting there where we go and say that, hey, this is better than the cloud provider router. But in terms of basic underlay connectivity, think of layer 3 connectivity, IP layer reachability. We leverage what the cloud providers give us. We don't want to reinvent the wheel in terms of connectivity itself. We have the edge presence from the cloud providers. We have the region presence. Amazon has AWS Transit Gateway, Azure has vWAN Hub. All these things are there. We leverage all of that. We leverage their backbone. We use that as an underlay. We build our application layer transit on top. That transit solves for the key outcomes that we have been talking about here. What does it mean for seamless connectivity? My app wants to talk to the database. My app wants to talk to the ML layer. My app wants to talk back to the data lake that's still running in my data center. All those are connectivity options. And then taking that one step further, how do I optimize for cost? How do I make sure that every transaction goes through multiple layers of security, whether it's federating with the identity provider, federating with different types of riskiness, understanding what is the risk level of each transaction, and also application performance. My web layer application can be optimized at layer 7, HTTP layer, but my VDI layer cannot be optimized at that layer because it's infrastructure focused. How else can I optimize it? How do I route the traffic? And all those things are taken care by the application transit in the middle. So they, again, run in customers' own infrastructure accounts. If I have an Azure subscription, I provide those subscription service principals. If it's AWS, I provide IAM credentials. Everything gets orchestrated. It's fully provided as a service. It's not an enterprise's responsibility to manage this infrastructure. They care about outcomes. All they have to configure that you'll see in the demo as well is what outcomes do they want? What applications do I want to onboard? And they just deploy that. And you also see the edge layer. That could be the cloud edge. Think of Azure Front Door, AWS. They have their own different types of edge services they have as well. We use Global Accelerator, for example. We also work with Google Cloud's edge. So the edge serves as to 2 things. One is for a fast on-ramp to the cloud. And if I want to, let's say, talk to an application that is sitting in AWS Frankfurt, one option for me is to go to Oregon, where a Prosimo edge could be running, and then Prosimo takes care of the routing back. Or if I go configure Fastlane option, which we'll show in action as well, then I can go to a Global Accelerator POP, which could be right here in San Jose, and then I jump into the cloud as fast as possible. So all those nitty-gritty details are kind of abstracted away from customers. They simply configure, hey, what do I care for with this specific application? Do I care for performance? Do I care for latency? Do I care for cost? And that's pretty much it. And we take care of all of the underlying constructs here. So that's in a nutshell. And this architecture solves for both use cases, user to app transaction and app to app transaction as well, irrespective of where the applications are run.
What does AXI stand for or mean?
Sure. AXI stands for Application Experience Infrastructure.
Okay.
It's just a term to explain that, hey, this gateway is just not another network layer gateway.
Okay.
The outcome here is focused on application experience. So that's why we call that name.
Cool. Thank you.
All right, let's double click on what are customers doing with this. So we looked at all the use cases that customers are deployed for, all the way from mid-size to very large size enterprises. And we picked the top 4, which are all kind of related to that multi-cloud transit use case. The first one is kind of deploying on top of cloud providers layer 3. I want an application layer transit, the transit which can understand user identity, which can understand application layer identity. Once I build this, think of it as a core network for the enterprise now. When we had a bunch of data centers and branch offices, and that's how enterprise networks were built, there used to be a WAN core. Now think of in the cloud era, it's getting replaced by this multi-cloud transit, which is starting to act as a cloud core, which enterprises can plug in their applications wherever the apps are and plug in their users, and then configure policies in terms of, I want these things to talk to these things with this set of outcomes. So that's a very common use case. Many customers are moving away from deploying virtual appliances in the cloud to move to this model. The second one is very specific application to application networking. Think of abstracting it to a service layer network. Hey, I don't care whether it's a lift and shift application. I don't care whether it's a modern Kubernetes service mesh-based application. Now, when one of the customers that had 47 different subsidiaries within their company, and each BU or a subsidiary has full freedom in terms of which cloud they could use, and they have their own credentials for a cloud, and they can go deploy their own application. And when they have full freedom, you really cannot control what IP address scheme they're going to use. You really cannot care about how many VPCs they may use, how they want to architect that. But as the common cloud platform team for the entire enterprise, I want to lay out an architecture and provide the guardrails to those developers and say that, hey, you can go configure this. And when you want that application to go talk to a data lake, when you want that application to go talk to your developer tools like Jenkins, which could be in another cloud, which could be in data center, those becomes your policies. You will have to configure in terms of what you need from that centralized infrastructure. And or if you want this application to be talking to your B2B partners. Many customers are working with that say that, hey, I have all these B2B partners. They're also sitting in cloud, but I really do not want to build a network layer fabric between them. I know these are the 4 applications. They talk HTTP. The other one wants to talk to my SQL database. That's my service-to-service networking. I don't know how they built the application. Now do I care? Can I build a transit which can make any app talk to any app? So this is becoming a super popular use case for customers that are moving to this NetOps SRE model that say that I don't want to care about tunnels, route, BGP. I want to leave that behind. I want to make just apps talk to each other. That's the second one. The third is the application platform owners. Primarily, I go build, let's say, a SAP migration project. I move that from my data center into 2 regions of Azure. And then I have factories all over the world. I have my teams using SAP from all over the world, and they want to access SAP, for example, or it could be Atlassian Suite. You name the application that you really care about from a performance perspective. The moment you migrate the applications, now we have to figure out how is that application behaving. You really cannot stop at, oh, I can make A talk to B, I'm done. No, this doesn't work that way in the cloud. Now, the stack that is sitting in the middle, which is the AXI edge or AXI gateway, is looking at each transaction, understanding the GET request, the POST request, say what layer can this be optimized, how much of content is reusable. If you take an Atlassian Suite, let's say Jira, for example, AXI Gateway will tell you that 50% of content are reusable content. I have CSS, I have the same project ID, the same screenshot that have been uploaded to Jira. I may have a development center somewhere in Asia Pac. I have, let's say, 10,000 developers. This is another customer use case I'm talking about. Their worry was that Jira was actually deployed in AWS US West. And most of their developers came from India, Singapore, those regions. And when they accessed Jira, it took them good 40 milliseconds to download all of the project IDs and so on. Their care about was, hey, I have the connectivity. I don't really care for connectivity. Can you really optimize the performance? I really cannot put this in front of a CDN. No, this is my core Jira internal enterprise application. This can't go through a CDN for a public-facing app. But I want to use the same cloud networking construct, and I want to improve the performance. So we deploy this stack. We actually put an AXI gateway in Mumbai, which is close to where most of the developers were. We have an AXI gateway here. We use the cloud backbone. We optimize for performance at HTTP layer, not network layer optimization. And then the performance just improved drastically. What used to take 40 milliseconds to load the page, it's taking a couple of seconds now. So there are use cases that are purely focused on cloud performance as they migrate to the cloud. The last but not the least is the zero trust secure access. Here, the buying center is primarily security folks. And their care about is, I don't want VPN anymore. There's big migration going on to ZTNA type projects and so on. Here, the core part is they don't want to send the traffic to another cloud. We worked with a couple of big banks. They said that, hey, we looked at all the ZTNA offering in the market. And then if I were to use such ZTNA, I really have to send my traffic to a middle mile cloud. I don't know where those cloud POPs are deployed. And then my apps are sitting in AWS and Azure. How are they going to hand off to that? Which breaks my application framework of leveraging an AWS edge, leveraging an Azure edge. All those are out the door. I simply want to leverage the cloud that I picked for infrastructure and everything. I want the cloud to be my hub. Can I also enforce security policies, contextual policies such as I want to check for a device posture. I want to make sure that every transaction suddenly, let's say it's coming from 2 different locations. I want to stop that. Anything that can be risky, I want to stop that. So this automatically becomes a cloud-driven ZTNA of sorts for all of your cloud applications. You can write your contextual policies and say that unless these conditions are met, again, not only during the authentication cycle, of course, you could do that with Okta, Azure AD, and so on. What I'm talking about here is at a transactional level security. Each session may have thousands of transactions. Even if 2 of them look risky, I want to block that. I want my network layer stack, which is the AXI gateway here, to be aware of the context, not only provide connectivity here. Those are 3 or 4 use cases that are becoming a common theme across our enterprise customers.
The question that I had is around use case number 2, where you mentioned business-to-business comms and setting that up. In that scenario, are you saying that both customers would be using your solution and you'd help connect them? Or is it one core customer that wants to talk to all these business-to-business relationships? They set up something that the other customers can go to and take advantage of?
It is the latter. So where, let's say I'm an enterprise, I'm the one purchasing Prosimo, I would be deploying the infrastructure. But in terms of what I need from the other side, is just in terms of how the application needs to connect. What ports are they talking about? Or do they have to connect back? Let's say think of a web application from Enterprise 2, which we have no control on. That's running in Azure US East. Whereas as a Prosimo customer, I have an application that's sitting in AWS US West. Now, if that needs to talk, I don't necessarily need to go put something on the other side. I can actually understand in terms of how they need to connect, what ports, what protocols, and then I can build that connectivity into that. I still need to onboard the application to the fabric, but I don't necessarily need to go deploy an infrastructure into their cloud.
Okay. You also mentioned on-premises a few times.
Yes.
What is deployed on-premises to take care of the communication or orchestration on something like a vSphere cluster, or if I'm running NSX?
Yeah, that is a great question. So in terms of the form factor itself, that's a good reminder for me to talk about cloud form factor. The AXI edges that run in the cloud are cloud native. Essentially, if it's getting deployed in AWS, we use EKS. It's all Kubernetes, auto-scaled up and down. Same thing for Azure. We use AKS, GKE. So all those are packaged as a kind of a virtual form factor. And customers that are VMware shop for data center, they say that I want this to be deployed in my data center, but I want this to be kind of deployed through my VMware stack or an OpenShift stack. So they could continue to use that as well. We tried to put this as a native Kubernetes for customers. What we felt was it's still evolving. We kind of packaged the entire AXI stack as set of VMs, and customers could deploy using existing techniques such as VMware or OpenShift just for the data center side. But for cloud, we fully take care of the deployment using AKS, EKS, and so on.
Okay, so you're deploying it as virtual appliances.
And not only deploying it, we manage the lifecycle upgrades. Everything is managed from the Prosimo SaaS dashboard. Our ops team take care of availability and everything, even though that service itself might be running in a transit VNet in your own subscription. You don't have to worry about, hey, if one of my AXI gateway fails, do I have to go spin up another one? Or how do I auto-scale suddenly if I onboard 10 more applications? All those are automatically done by our ops team.
Is that AXI gateway doing anything with my on-prem networking, like manipulating NSX or hooking into firewalls or anything like that? Or is it purely just helping communication egress from that location to the cloud backbone?
Yeah, it is both ingress and egress. It doesn't participate along with your existing network layer or anything else that might be happening within the data center. That's something we have looked at to figure out maybe should we integrate with NSXT or ACI, but we haven't gotten there yet. It's essentially a service that you can hook into your existing network on the data center, and we need to figure out the ingress and egress path for that. That's pretty much it. It automatically joins the existing fabric in the cloud, and that way data center applications can go talk to the cloud applications and vice versa.
So you mentioned that the appliance is managed by your ops team. Are you positioning this product as a fully service provider where the customer really doesn't have to interact with as much, that you provide it, service it, maintain?
So in terms of go-to-market, there are both options are possible. We have large enterprises that are directly working with us, where we provide them the SaaS dashboard access, and then we go discover all their cloud presence. And then they say that, oh, here is what my AXI footprint should look like. A couple of them in Asia Pac, a couple of them in Azure US, and then that gets maintained by us. And then there is also second go-to-market. We are working with large telco partners, large SIs that are helping customers with cloud migration. So they go work with customers and say, as a part of the migration, I'll also manage this entire infrastructure. So you don't have to worry about networking in the cloud, security in the cloud. These are all outcomes that I could provide. So we have telco partners and SIs that are doing that for customers as well.
I have a question. Hi, I'm Karen Lopez.
Okay.
So I'm really happy that you provided good use cases that I can get my head around for doing this and multi-cloud. But I also, in my day-to-day job, worry about the performance of systems based on their architecture. And we can barely tolerate performance of applications that are in two geo-paired regions, like in the same country. But you've given lots of great examples of, other sides of the globe, multi-cloud, another layer. Can you talk a little bit deeper about the actual types of transactions or use cases to say where physics is going to get involved of doing these things, where this would be a good solution versus trying to move applications so that we can overcome the physics themselves?
Yeah, absolutely. I'll take the SAP or Jira Atlassian Suite example as well, again, to walk through in terms of what does it mean. Let's say in this case, think of a customer that might be based in Germany, and then they have applications that really cannot go outside of their country for local compliance
data sovereignty
reasons. Exactly, so data sovereignty reasons. Now, a copy of the application or another instance of application could also be in North America. Mm-hmm. In this case, you could go write a policy saying, if my users are coming from Germany, they might be hitting the AXI gateway, which is our fabric. They should all be routed to this specific instance of the application. Whereas if anybody else comes from North America, rest of the world, they should go talk to the other instance of the application. Mm-hmm. Because the transit itself is aware of multiple instances of application, and then you can write a policy in terms of who should get routed to where, depending on the geolocation as well. Because the fabric is also geolocation aware. When the user makes a transaction, we can figure out, okay, Karen is coming from North America, somebody else is coming from Frankfurt, somebody else is coming from Singapore. All those are aware, and then we should be able to route the traffic based on compliance reasons. Mm-hmm. And even we can actually, anything that we cache to improve performance, it also get cached based on the data sovereignty requirements. We don't cache something that is very specific to German customers in North America. Those things are automatically taken care of. Yeah. Very good. Now I'm going to talk about the consumption model real quick. We have multiple types of consumption model. It should be as simple as just going to our trial portal. Hey, I want to start a trial. And a lot of the cloud platform teams start this way. That way they can experience the platform. They can get everything up and running in a couple of hours and say, hey, here is a test application or staging application I want to test with. That's one model just to get going right away. But in terms of consumption, most customers now in enterprises are preferring the cloud marketplace-based model. Reason being, we can go send them a private offer, and that private offer kind of gets built into their cloud subscription target of sorts. Today, let's say I have X amount of budget set aside for my AWS consumption, and then same thing for my Azure consumption. Now, Prosimo could be consumed as a part of that. That's becoming a super popular model. So we're not only in marketplace, we could transact with enterprises using private offers as well. And in addition to that, we have large SIs that are providing this as managed service. And last but not the least is the direct offering, where we could provide using the trial to a pilot to a full consumption model as well. Those are different models that we could offer to customers today. So to summarize again, how is Prosimo different? Just to kind of wrap it up here. This is not a network layer overlay. I want to be very clear. This is not, hey, I can have two IP-based islands connected. I'm building my own BGP and then I'm kind of masking from customers. No, this is not that. This is entirely working based on application identity and user identity. The transit that we're building in the middle is based on all of that. So we could solve for 4 or 5 of those key outcomes we promised to customers. Reducing the attack surface and then providing the zero trust access, providing seamless app-to-app connectivity, seamless user-to-app connectivity. What does it mean for cost management? All those things we've been talking about. You will not see node knobs, and then you don't have to worry about, do I turn on this TCP optimization? Do I turn on this HTTP layer optimization? Those are all masked. You tell us, what do you care for this application? Cost reduction or performance improvement? All those get taken care as an outcome. Lastly, this runs in customers' own subscription. We did not intentionally want to become a middle mile provider of sorts and ask customers, say, send traffic to us. We really want to go to customers and say that, hey, this is your cloud, and we will operate this in your cloud. That way you have full control of your data, certificates, visibility, transactions, everything. So that's how we are different. With that, all these use cases I talked about, we want to show to you in action so you can ask and see for yourself.
I have a quick question for you, if you don't mind.
Sure.
How does this will be a weird question, but I think a lot of us are wondering, how does this plug into my network? am I setting my router address to the AXI? Am I reconfiguring my applications to talk to it for specific use cases or specific interfaces? How do I plug into the AXI
I
environment?
think that will be best shown in action. That way you can see that this is how I onboard, this is how it plugs into my current network. You can see that in action, and Faraz showed this in a minute now.
Okay.